Okay, let's talk about the probability of a spinner. So, raise your hand and tell me what the probability of spinning a yellow is. How did you get that?
You counted the yellows and I counted the rest of the colors.
Good. We've got 1 out of 2, 3, 4, 5, 6, 7, 8 possibilities. Now I probably my red. See that?
1 half.
How did you get 1 half?
Because I got 4 eighths of the special sided.
I have 4 out of 8 of those pieces, which simplifies to 1 half. Good. What about my probability of my blue?
3 out of 8.
Somebody else raise their hand in the end? 3/8. If I just counting, right? What about not blue? Sarah, where did you get 5/8 from? Okay, you just counted. 5 of them are not blue. We could say the probability of not blue, we could say is the probability of the yellow plus the probability of the red. You could look at it that way. Correct? And the yellow was 1/8, and the red was, what did you get? 4/8, which equals, see, probably pretty good. What's another way to do it? Julie? What? Subtract the blue. Good. So I could have done it. The probability of not blue is the probability of all of them minus the probability of blue. Did that do it? All of them and subtract the blue? Good, my higher. So probably what's all of them? Probability of not blue. Probably of all of them minus the blue. What's all? 8/8 minus 3/8. Another way to write this, another way to write this is to write it 1 minus the probability. Why in the world would I write a 1 there? It's 8 over 8, so there's no reason why I would write a 1 there. 1 whole, or how about 100%?
Oh, we're looking at percents now. Because 1 is equal to 1.
Well, when we're talking fractions, are we talking a percent of something?
Yes.
When you're talking fractions, you can always be talking in percent, correct? Right? How much is a fourth? 2/3. Alright, so move on. Alright, so I'll be able to create a sample space and create a probability distribution to help in calculating probabilities. So we're going to start touching, we're going to do what we did yesterday, right? Where we had a histogram, and we're going to add some probability into that today. Let's look at this. Here's our big idea. This is what we did yesterday. A frequency histogram. So if we're talking about exam scores, so we've got our different exam scores down here, and over here we have the frequency that they occur. So it looks like between getting a 0 and a 20%, I say about 2 people got that. And here, it looks like about 5 people who got between 20 and 40. Between 60 and 80, it looks about like 20 students. And I say 12. See if I can do anything right here. 10, 20, 30, 37, 47, 20. that's what that kind of information is giving me right there. I've got 60 students, and I've kind of organized it into a histogram. Okay, so what's the other one look like? It looks a little different. It's called a relative frequency histogram. So talk at your table, compare and contrast those two. Go. Raise your hand. What you guys happen? You know?
On the y-axis, going by percent.
Good. This one's going, it's relative to the percent, right? This one is just talking frequency of how many we have. This one is relative to a percent. Right? We can compare each one of these on a percent. What else do you notice? I said compare and contrast. So we don't have to have something that's contrasting, we have something that's comparing. Okay, let's hear it. Good, the height is up. Good, yeah. What do you notice about the x-axis exactly? There's some certain things that make it definitely a histogram. Okay. So Casey's saying they're equal segments. Did we remember that word that we used yesterday? What's your mind?
Full.
Interval. Good. So the intervals are even, right? They're all the same. Each interval is the same. Counted by 20, 20, 20, 20, 20. What else makes it a histogram? Caleb? The bars match. Good. Perfect. Right? We're looking at data. Alrighty. So you roll a number cube. Let's talk about that. Rolling a number cube. And we call it a die or a dice, right? So you roll a number cube. What is our sample space? What would that look like? Think of sample space as your desk. Okay? And I thought about actually getting everybody to
We're too small.
You're too short. I would love to be able to get it to you. All right, so just imagine that just every visualize, right, that you've got a number cube on your desk. What, and you roll it. What would that sample space look like? What could you roll?
You can roll a 1, a 2, a 3, a 4, a 5, and 6.
You could roll all those numbers. Okay? Okay, probability of each outcome. So we're going to talk about the frequency that this occurs. Or relative frequency. So do you guys remember what was involved in our relative frequency here? So we have percentages, right, for the ratio. What else do we have here? C stands for? Alright, so we're going to make, I have probability of each outcome. On your homework it says frequency table. It's really a relative frequency table. Right? Okay. So we're looking at the probability of it happening. That was the y-axis. What does that depend on? What does the probability depend on? The variable. It depends on because sample space more simplistic, guys. Don't even think about being all fancy about it. What's the probability? What has to occur and what's for the reference probability? You have to roll a number. Right? We call it our outcome. So the probability depends on the regular outcome. So what are my different outcomes? What's the probability of rolling a 1?
1 over 6.
And a 2. And a 3. All of those. Let's try this round. Ooh, this one's going to be kind of boring. Right? They're all the same. So, what do I got there? A 1, a 2, a 3, a 4, a 5, and a 6. 2, a 3, a 4, a 5, and a 6. What's the probability of it happening? I can pretty much put it wherever I want it. 1, 6, right there. It is so uniform, Sarah. Thanks for noticing. It's very uniform. What does it mean to be uniform?
It means no, like, saying constant.
Let's turn around. Turn your chair. All right. I want you guys to try to give you 2 minutes to try this one on your own. Try to come up with a sample space, and then what you can call my relative frequency table is going to have 2 different things. What are we going to have it? Outcome and what else? So we got
Because math equals each other.
We've got either red or green or blue. I think I put that over here already. I've got red, I've got green, and I've got blue. Let's look at the probability of each one. Okay, so my outcomes are red, green, and blue. Look at that, it's going to be 2 minutes. What's the probability of getting a red? Philip? 1 out of 3. 1 out of 3.
1 4.
Don't you just count it?
What do you think? No, why? 1 out of 4.
Because
First you said 1 out of 3.
I think because you have cake. You have like the red and the green are split. So the blue is like the whole half.
Is it fair to say you only have 1 chance to get a blue?
No, you have the same amount of chances that you have to get a red and green. So
You do have 2 chances to get a blue.
equal.
Okay? So if we're looking at as breaking the board up evenly, right? You actually only have 1 out of 4 chances to get red. 1 out of 4 chances to get green, and I'm going to call it 2 out of 4 for blue. I don't want to keep it comparing 4 to 4. So if I were to write this, I would say I'd probably write 1/4, 2/4, 3/4, 4/4. What would 4/4 represent? The whole thing would be blue color, right? Alright, so just have to go here. This would be 1/4. My green would be 1/4. And my blue is going to be 2/4. So 1. Maybe you need more even, so I need to change this. If this is 1 and this is 2, then this needs to be 3 and 4. That's better. Better? Yeah. More cut? Ready to move on? Okay. Let's flip a coin. Okay, there's one very similar to this on your homework. 50-50. I'm going to do this one a little bit more complicated. sample space first. Actually, before I talk sample space, it's about probability. When we talk about probability, what are we talking about again? That something's going to happen. What are we comparing when we're looking at what something's going to happen? The outcome. And what else? The probability. The probability of each outcome. The probability of each outcome. Exactly. And the probability of each outcome. Okay? So this says, specifically, we flip a coin 4 times and you consider heads as a success. So we're looking for successes. So what would you consider, Janae? What would you consider? I know you guys are working on what you're supposed to, but I want you to pay attention for a second, okay? So what would you consider a success then? Very good. One word. Head. Head is a success. If I flip this coin 3 times, am I always going to get head?
No.
So what would I call it if I don't get head?
No, what's the first?
I'm only considering whether I get head or I don't, and I'm counting. So what would I say if I didn't get a head?
Oh, no.
How many heads would I have?
0, 2, 1.
Wait, repeat your question.
Totally right.
So the only thing I care about is head.
Yes.
Either I have a head or I don't. So what happens if I don't have a head?
Zero.
What happens?
Zero.
So that's my first outcome. Isn't that a possible outcome?
Yes.
Having
0, 1, and
what's another possible
1,
outcome?
1, 2, and 3.
1,
2,
2, and 3. Do I have possibility of having 4?
if you flip it 4 times.
It does. I'm going to flip it 4 times.
There you go.
There you go.
We're just talking about 3.
Oh, because your homework says 3. Sorry. I'm going to make this a little bit smaller. Yes, Kristen. The homework says 3.
But the thing about 4 is that you can get 50-50.
Yeah.
It's like when you flip odd numbers, you don't get 50-50.
Alright, ready? I gotta figure out how to look at this different sample space.
Can we flip with a real coin?
So you flip a coin, and what are the possibilities?
50%.
50% each time, okay. That means
Well, because if the coin has 2
there's
sides,
only 2 different outcomes. Your heads or not heads.
yeah, so it's 50%.
I can use heads or tails, or head and no head. Couldn't I?
Yes.
Use head and no head. Either you head or no head. That's the first point. That's it. Everybody agree that those are my 2 outcomes? That's my sample space? 1 point. Let's flip another one.
Okay. Wait, what'd you get the first one?
That's the first coin toss. First toss. I got heads or no heads. So this one, right? Let's say we took this scenario. This is the only one I'm going to think about is this one. I'm not even going to pretend like I got no heads. Let's first do a head. The second time I flip a coin, what are my 2 outcomes? Heads or no heads? Okay? Are you going to say your name this time?
Heads.
Heads? Okay. So the third time you flip the coin. The third time.
You get heads.
I get heads
Yeah,
or
because you're feeling good. You get heads.
or no heads.
You get heads. You get heads. I hate that one.
You get your heads again?
Wait, really?
Would it work better if we fail?
No, it's just weird, like heads. Like you just when you talk, like just say words like enough times, you're like.
I hate that when you keep saying
Are you
words.
saying that?
Yeah.
Keep saying words.
So you guys said I got a head, then I got a heads again, then I got a heads again.
Yeah. Then you're gonna get no heads because you're stopping.
Let's just say I got heads.
I just think I like one case because
What? I gotta go. You got no head. No head. No head.
On the face of the coin.
But no head.
Right? So I got all four heads.
100%.
All the rest of these outcomes here. I have other choices. I think if I got all heads, okay? I could have got no heads, and then I would have had choices of heads and no heads. And then I would have had choices of heads and no heads off of this one. It's like a doctor. Is that all of them?
Why'd you wait this long?
Let's make sure. This one gets two different options, this one gets two different options, this one gets two different options. So I actually have all these different options, and you're ready to go. I did all the heads. And then I did head, 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 no head. Okay?
Yes.
Then head, head, I already did all these, right? So now we can do this. I did all these. Then I went all the way down and did the no head. So I'm done with all of that. Okay? Now I've got head, head, no head, head.
How long is it?
Head, 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 no head, head, and head, head, no head, no head. Head, head, no head, no head. Correct?
Yeah.
Right? That takes care of what? This right here. Right? Correct? Now I gotta do all these.
Yeah.
And the no head.
Okay, but what's the, where are you getting at? What's the point?
Head, hold on, I've got to get it somewhere. Head, no head, head, head. Right? Then the next one would be head, no head, head. You know, this is pattern happening.
Yeah.
The only thing that's different from this one to this one is the second one.
Yeah. So change
The only thing different from this one to this one is the second one.
and for you.
The only thing different from this one is going to be what?
Yeah. Okay, but what's the point?
Let's double check. This last one would be head, no head, no head, no head. Head, no head, no head, no head.
Yeah.
The one on your homework is only 3, so you don't have to go that far. Okay, just go somewhere. So they're going to take care of all these. Are these going to be the same? And these only what? The first one's going to be N and not an H.
Yeah.
So how many possible outcomes do I have? 17.
Then you have a whole other set.
I wonder if we can do this without writing all the rest of them down. How many are we going to have no heads? Well, how many do we have all heads? 8. So when I finish this, what do you think it's going to be? How many am I going to have where it's all no heads?
One. Because look, you have to look at the set.
Right? The very last one is going to be no heads, no heads, no heads, no heads, right? All right, so I'm going to have 1. How many do I have of just heads? other kind of sorry.
Well, it's gonna be another turn.
There's only one of them that has no head here. I almost just want to give you guys your homework, and once you start listening on this one, and I'll make you 3 instead of the 4. Okay, let's see what I'm at. I'm going to come back in about 3 minutes, and we're going to talk about it. Alright, so number 3 in your homework is you roll a 6-sided die twice and find the sum. So I'm going to find the sum of something. First thing we're looking at is what that relative frequency table, right? And when I look at the relative frequency table, I'm looking at outcomes and what else? Outcome and probability. What are my possible outcomes if I roll 2 die? You got 2 die on your die. And you roll 2 of them. What's the lowest possible sum you can get? 1. You have 2 of them. What's another possible outcome? 3. 24? There you go. I need you to get together.
Oh.
Okay, so there's our outcome. We got to find the probability. The best way to come up with a probability is to make a sample space, right? This one's a lot easier to use a table. So I've got rolling a 1, a 2, a 3, a 4, a 5, and a 6. And on the top I have rolling a 1, a 2, a 3, a 4, a 5. How many different outcomes do you have? How? When did you do that so fast?
You multiply it 6 times.
Multiply 6 by 6.
It's almost like that. What is that table? No, wow. It's like the 4 square table. Is that almost 15?
So if I roll a 1 and a 1, I'm going to get a total of a 2. And I roll a 1 and a 2, I'm going to get a total of a 3. And the 2 and a 1 would be 3, 4, 5, 8, so on and so forth. Okay? You guys can fill out the rest of this? Okay? What would be the probability of getting a 2? One in how many? When you have a total of 36, am I ever going to get another 2? If I add all these up, a 6 and a 1, a 6 and a 2, am I ever going to get 2? No, so the probability of getting a 2 is 1 out of 36. What about the probability of not getting a 2?
Oh, that's
Very
right.
sorry.
The probability of getting at least a 3. That would be 35 out of 36. Right? Because the probability of getting a 2 is 1 out of 36. There's 1 out of 36 chances. So the probability of getting something more than a 2 is going to be all right. What's the probability? It's 1 minus the probability of a 2.
Maybe that's what, you don't interact with them at all, like I would interact with them. I was still recording. I can stop it. I can